can stretch our budgets is by using salt instead of cinders on our highways. When using salt, which is an expensive item, we can extend its usefulness and make it a little bit cheaper by using liquid calcium chloride. This little demonstration will show you exactly what I mean. We're going to take salt and we're going to wet it with liquid wetted calcium. And we'll bounce it on the table too. We're going to wet this salt with approximately 16 gallons per ton of calcium chloride. You'll notice that when it's wetted with liquid calcium chloride, instead of becoming very, very bouncy, it becomes rather nice to handle and just lays on the table when it's thrown on the table. What we want to demonstrate is how it works as far as melting ice is concerned. So we'll have some highway ice from your local 7-Eleven. Now what we'll do, we have 4 beakers here. In beaker A, we'll use just ice alone. In beaker B, we'll use ice treated with anti-skid, because everybody knows that anti-skid does not melt ice, correct? We will also use dry salt, that'll in beaker number C, and in beaker number D, we will use wetted salt. We will use the same amount of salt for each application. Okay, beaker number A, pure salt, pure ice, excuse me. We'll put it back on the highway at 32 degrees. In beaker B, we will use anti-skid material. In beaker number C, we will use just regular dry salt. And in beaker number D, once I get all the stones out of it, we'll use wetted salt. Now we will put some traffic on this. Now, because it takes...
While Dawn's samples sit for 20 minutes to simulate field conditions, we'll look at one municipality's experiences with wetted salt. Montoursville, a borough in Lycoming County, has developed their own method to pre-wet salt.
Borough of Montoursville again. This is our calcium chloride application for our salt pre-wetting. This is a 2,500 gallon storage tank. For the calcium chloride, we get 2,000 gallons at a time. Depending on the winter, how long it lasts. This tank lasted us somewhere around 2 winters. We piped this in through the building with a valve and plastic hoses to go in the building. We started using calcium chloride. We had to set up a pumping system to get the calcium on the truck and on the salt. We had to run a 110 line, bought a small pump. This pump is a 15 gallon a minute pump that runs it through this hose, and we just put the back the truck up to the door and take this hose out, open the valve, and put it on the salt. We were pre-wetting at that time on the bucket and dumping it in the truck. Since that time, we were metering it. We were putting on whatever we thought, it was a by guess and by golly method, whatever we thought calcium we needed on the salt depending on the temperature outside and the type of snow. Since that time, we've changed our truck over to have a wetting operation as the salt comes on, which I'll show you next. Salt application truck, 600 Ford 1988 model salt spreader truck were bought together. It's 10 years old. Like I said, we used to pre-wet our salt, and since that time we found that pre-wetting was a bit messy. Since that time we purchased the tank you see in the right of your picture to carry the calcium chloride in. Then we pumped that calcium chloride out of a hose, come across here the white hose you're seeing, into a control box. The control box has nothing more than a liquid pump in it. It pumps out of that, goes up to a valve, which is where we set our control for our calibration for how much calcium we want to put on the salt at that time. It goes in through this. We have two nozzles on the back of the salt truck, and as the salt comes out through the feeder, the conveyor unit, the calcium sprays on the salt. Works very good. Made a lot less mess with handling calcium chloride. The only calcium we put on it is put on right as it drops off into the spreader and goes out the spinner. We find it real efficient when we have snows where it's icy. It makes the salt work a lot better. We use a lot less salt. Our truck holds approximately 5.5 tons of salt. We do our whole town with less than 2 loads of salt on a normal snowfall. This is a better look at the tank on the side of the truck. It has a plastic plug in the top of it where we put the hose, and we just turn on the pump, fill up the tank, set our calibration with our valve on the other side of the tank, and we're off and running. Picture is a control panel for the spreader, dials for conveyor, and also spinner speed. The toggle switch you're looking at on the left is the on and off switch for the calcium control pump. If we don't need liquid calcium on our salt, you just turn it off in here. As the operator sees it getting the icy condition, he flicks this toggle switch and the calcium control pump goes into operation, and we get calcium on our salt. So we only put the calcium down as needed.
As about 20-25 minutes has now elapsed since we put our samples in under our highway conditions at 32 degrees. We will now measure each and every one of these beakers. Remember, beaker number A was ice alone. Very, very little water, if any water whatsoever. Just a trace. Beaker number 2, as we saw, was the anti-skid material. Many townships use quite a bit of anti-skid material. As you can see again, barely a trace of water. Anti-skid material, maybe a half of a milliliter. Beaker number C was just salt, pure salt. As we can see from the pure salt, we got melting action at roughly 27 milliliters. Now remember, we used the same amount of salt. All we did with the salt in this beaker was we wetted it with liquid calcium chloride. Absolutely no difference other than the wetted calcium chloride, and we're up to 40 milliliters. Quite clearly then, if we use salt alone, we're going to melt ice. Anti-skid material melts no ice. But if we wet that salt with liquid calcium chloride, we're going to increase the action of that salt by at least 20 to 25%. If you do have any questions, please feel free to ask your instructor.